Kerajaan memandang serius situasi semasa ancaman virus berbahaya ini, terutamanya perkembangan gelombang yang kedua.
Amid rising COVID-19 cases in the country, Malaysia has now announced a complete nationwide lockdown for all its social and economic sectors to curb the spread of the virus.
Situasi semasa wabak ini memerlukan tindakan drastik diambil bagi memulihkan keadaan secepat mungkin.
Peningkatan pesanan makanan dalam talian menunjukkan angka yang positif kebelakangan ini. Mengikut laporan media di Singapura, GrabFood menunjukkan peningkatan sekurang-kurangnya 20% dalam tempoh beberapa minggu yang lalu. Namun di Malaysia, beberapa syarikat penghantaran makanan dalam talian mengakui jumlah permintaan yang agak memberangsangkan diterima dengan penghantaran langsung ke kediaman mahupun ke pejabat.
Ay, 救命！濕晒，張凳濕晒，全身都濕晒。另一個矛盾嘅位就係通常你落雨先會多生意啦、多單啦，同埋公司會俾多啲錢你咯。所以其實係一個 trade off 嚟嘅，睇下你願唔願意用生命去賺錢咯。之前自己就係落雨嘅時候發生交通意外，所以有陰影咯都。一向右傾側嘅時候咧，就反咗啦，就個人飛咗去左邊啦，然後架車又去咗右邊啦。
Generally, the design concept is more important part in this project. This sketching concept consists of 6 designs of the aerodynamic roof structure prototype. Each of us came up with our own idea or creativity on how we want the aerodynamic roof to look like. For the design ones, is apply a scissors mechanism for retracted process of the roof. This will make the roof portable as the rider can just bring the retracted roof at the back of the motorcycle whenever the rider wants. So, for the roof, a simple pin joint in the housing will work fine because slow speed and infrequent operation doesn't require anything more advanced. For the box, we have 2 layers. First layer is the frame of the box, and second layer we cover it with the same materials for the roof cover. The material of the roof is made by aluminium, while the windshield is made by polycarbonates, and this design requires a monorack to hold the storage box at the back of the motorcycles. While for the design 2, this design requires to fabricate a huge part which is the roof and the front windshield. The left figure shows the fully extended roof. This roof covers the top sides and the front side of the motorcycles. The design can be used even there are 2 people at the motorcycles, because it has a base at the rear side of the roof. The right figure shows how the roof are kept. The roof is linked with the door hinge which allow the roof to act as a Z shape when it's needed to be kept. The roof is secure when a toggle at the windshield which is located at the upper part on the top of the left and the right side. The windshield sides are quite big, but it can prevent the rider from getting wet. And for the design 3, the windshield is not straight at all but have a slight curve for better airflow, but this design requires excellent cutting skills. Besides that, this design also have a rear monorack to mount at the roof of the top. But this roof is not foldable, so it has a problem with the portability of the roof. In case the rider does not want to use the roof, it has to remove completely and may consume some times. But for the design 4, this design is similar to the design 1, which also have a front windshield at the upper parts of the front side and extend the roof from the rear. But this design does not have a box to keep the roof. The roof is attached to a clip at front windshield when it extends. The roof structure is made by aluminium as well. The material of the roof is canvas that prevent from rain, water and sunlight. Also, this design is not covered for the lower part for the front side, but it is portable to the rider. While for the design 5, the front windshield is proposed to use tempered glass, while the roof is using an umbrella fabric. The front windshield of this design is mounted at the front side, but it has 2 pillars on both sides which may cause some blind spot or affect the comfortable of the rider. The final design was developed using SolidWorks software. Each component of the design was created separately before assemble. Our group has chosen the combination of design 1 for the roof and the design 3 for the windshield as our final design after taking a lot of criteria into account as we had discussed in the topic. Design 1 roof is mainly chosen due to its capability to be portable and seems to be most rigid design in terms of the roof. However, it may require a lot of hard work in order to fabricate the design. For the windshield, design 3 windshield is mainly chosen due to its capability of covering both upper and lower part of the rider. Moreover, it provides better airflow compared to other designs as it is important to keep the airflow in the greatest condition to avoid the product from taking a lot of pressures or forces during raining and heavy winds. So the final design of the product are created by using SolidWorks.
We have run a few of simulation tests for our product, which are airflow, pressure, drag force and lift force. First of all, the airflow. Air is flowing with a speed of 60 km per hour applied as an external flow. Figure shows the pattern of the airflow from the front view. The table on the right side of the figure indicates the velocity reading of the airflow based on the color of the arrows. The advantage of this type of streamlines are further we zoom in, the more details we see. And it brings a perfect understanding how the airflow around the bodies. Next, the lift force. Table below show the result of the lift force generated by the simulation. Global force in y direction is taken as the lift force. As we can see from the table below, value for the lift force is taken from the minimum value of the lift force, which is 1283.012035 Newton. And next, beside From the table below, we can see that the values of the drag force and the drag coefficient, the value of the drag coefficient is acceptable as the value of the drag coefficient of motorcycle should be within 0.5 to 0.8. Thus, the value we get, which is 0.722657816 as the drag coefficient, is acceptable in this case. We will proceed to the engineering economic. The table above is the variable cost, while the table below is the fixed cost. The variable cost is 584.24 ringgit. The fixed cost is 159 ringgit. And we have do the brick analysis for this product. This is the step to calculate the brick analysis. This is the break-even graph we obtained from our product, and that's the return of investment. And finally, is to say that after the calculation, we will have a return of investment which is equal to 60.92%.